Okay, I'm from Hong Kong, as you probably know by now. It's still there. A bit of problem over there, so if you go there now, you wear your mask. You should be okay. The title of my talk, as you can read, are those characters up there. If you cannot do that, then I will explain to you later. Okay, the story, forget about the, why is it only, there should be a that should be English. Anyway, suppose you are a very young boy, 9 years old, and early in the morning, 5 o'clock, you take your underground and everything else to come to school, AA or whatever. And then on the other side of the river, this is the river, is your school, and the water is a little bit high on that day, and you need to make a decision whether or not to cross it to go to school. So what would be your choice? And so on that day, the boy and his mother chose to cross the river, and a few days later their body were found because the water was a little bit too high. So that was the beginning of our investigation and our One University, One Village or Bridge to China initiative. Can we architects find ways to help these people, but ways that are more sustainable than just build a normal bridge? So we went back to Hong Kong and we told the students in our university and the problem, and they all say, why don't we just do our next studio, building a bridge for them. So they call it A Bridge Too Far after the movie. You probably know the movie. Because at that time, we don't even know whether or not we could do it. The river is about 100 meters across. And for an engineer, it's easy. But over there's almost nothing. So for a bunch of students trying to work on it, it's quite almost impossible, I would say. So the students then start to investigate what is needed. That actually was the bamboo bridge that they make every year, which you see here. And how the water behaves and how people use their kind of bridge. Then we contacted my teacher, Anthony Hunt. How many of you know Anthony Hunt? No, probably some of you still remember him. He has retired, but he was the engineer for Foster and expensive architects. So we went to see, he was my teacher, actually. And I went down there and say, I need to build a bridge. Can you teach me? And say, you forgot everything I taught you? I said, yes. So we start again. And then, as you can see, the sketch, there are some of them upside down, and it's by him, or some of them are by me. And the problem with him is that he's very good, but he's very expensive. The way that he designs is also very expensive. So we cost one of the earlier prototype that he designed. It cost a few million Hong Kong dollars. So I went back to him and said, no, we don't have that much money. He said, how much do we have? He said, well, $2.50, that's all we have. And that's include your fee. So he say, okay. He say, right. We start the whole thinking process. They say, okay, this is how the villagers build their bamboo version of it, and every year the water comes and then it will be destroyed. I say, why don't we just use that as a basic principle, knowing how they do it, and then we just do it slightly better in such a way that the bridge will survive 95% of the time, or 95% of the time, the bridge will be crossable, but only 5% of the time, the water will come. The plank will then be dislodged and then sink to the water next to it. And after the water is gone, then you pick it up and put it back. In doing so, you don't need a big foundation. You don't need concrete. You don't need a bit of stone and some steel wire. And that's how the bridge should be done. So we look at it, it's a very sustainable and appropriate way to design something that works. And that starts the whole process of us using natural material to help the villagers. But the design of it is quite difficult in terms of engineering calculation. For example, we designed the plank in such a way that if we were to use a normal way of designing that plank, it will be about 300 mm thick, and there will be 1 ton, so nobody will be able to carry it and put it back. So Tony designed it in such a way that it's only 150. It's very clever. So we designed the whole thing so that everybody can work on it manually. And then we bought on site a number of student workers. These are all the students. I told them that if you get washed away, then we'll pick you up later. Don't worry. Oh, by the way, there's one story that I need to tell. This cage. They are not normal cage. They are gabion. Gabion are they normally used for protecting riverbank. So the best gabion manufacturer was in Italy. So we went to Italy and say, can you donate just some of the cages so that we can work on it? The Italian guy said, no problem. Okay, no problem. Okay, so he said, but you have to be responsible for your transport cost. Okay, we can donate all the cages to you, and good luck. Then we were worried, and then when we were worried, and he said, hey, come on, and I said, you know Italian, how they behave. I said, hey, come on. Okay. All our cages are now made in China, don't worry, we ship it back to Italy. Okay, so we went back to China and find the factory that the company actually make the gabion nowadays. They all made in China now. So we ship it from his factory near Shanghai instead of from Italy. So that was how Made in China is now well known. Okay, so these are the cages. They are guaranteed to last 50 years, i.e. after I'm gone, the bridge will still be there. And then the students are very nice, and they try to help us moving the rocks, and we try to help ourselves by moving the plank onto the pier. By the way, we did a statistic analysis of how the students help us. We finally realized that the bigger student will carry the smaller rocks, and the smaller student will pick a big rock. So you see, the size of the rock is inversely proportional to your IQ. So that was the final plank, and how the whole things work together. That's the end of the 5 days of work. It took us 5 days to build this particular simple bridge. As you can see, it's very similar to their bridge, but it's just that it can be crossed without problem 95% of the time. And this is how we test the bridge. So by putting everybody up there and take a photograph, if they survive, then that's it, then the bridge is safe. Luckily, we entered the competition, the RIBA, and we won. That year, Norman did not win anything because his bridge was still wobbling. So he got a water, I think later or something like that. But he asked me to go to his office to give a lecture. And he would look at me like that and he said, why your $2.50 bridge can rival my 20 million bridge, okay? And it doesn't wobble. And after the lecture, he actually started his own charity, building schools for Africa somewhere. Not very good, okay. Anyway, so we know that he was trying to build schools, so we tried to build a school to make sure that he has a hard time. So, this was the original school that I'm quite sure you know roughly how it works. Very dark and small, but then the kind of new school that the government was building was not appropriate because it's very cold in the winter and extremely hot in the summer. So after the school was built, actually the students went back to the original school to have lectures, and then rent it out for storage. So they have some money. So they okay. So we thought maybe we could design a house, a better school for them. This is what architects should do. I mean, we should try to find ways to design our buildings to do better, okay? Better school, better whatever. So we look at the, I'm quite sure all of you do that nowadays after the lectures in your environmental, sustainable, whatever, that you check your weather data. And once you look like this weather data, you know exactly what to do. So can anyone tell me that the first thing you must do for this kind of weather is? Come on, guys. Is what the only thing that you have to do to make sure that your building works is look at the weather chart. Come on, hey Alice, you've been my lecture, you should know.
Thermal mass?
Thermal mass, correct. Okay, thank you. Actually, I told her this morning, so just to make sure that somebody answered the question. Thermal mass, because of the high temperature swing, you only need to use a lot of mass to stabilize the temperature. Once you stabilize, then 40 degree and 10 degree become 25 degree. Your interior will be at 25 degree, okay? So that is how we should somehow find a way to look at this kind of weather chart and say, yeah, this is a few things that you must do. Of course, there are other things like daylighting and also fresh air that you need to incorporate into your design, but that comes a little bit later. So we then measure some of the buildings that they have, and then we find out that actually the traditional building, the caves, actually are more stable, whereas the school that they built by using brick is not very stable. So if a school is built like that at the bottom, then you won't be too comfortable in the winter and in the summer. But whereas on the other hand, if you built it with earth, like a cave, it is better. But on the other hand, I mean, the cave can only be very small in terms of volume. Then you don't have daylight and you don't have fresh air. So you have to solve some of the problem by combining the traditional wisdom and also the modern kind of scientific know-how. Then you can find a way to design schools better. I have a finger. Okay, and then the other thing is that if you, as I have learned from my teacher, if you want your building to be cheap, then the local has to know how to do it. Otherwise, you can employ somebody else from outside to build it. It would be very expensive. So we know exactly how the locals build the buildings using earth and their tools and things like that. So we learn from them. This is actually a part of a PhD thesis of one of my students, trying to see what are the kind of techniques that one might use for this kind of situation, from very, very simple wall elements to more complicated incorporated systems. So every time you do something, you improve the performance. So you just need to do some analyze and also calculation, simulation, to make sure that you know exactly what you're doing. But there are many different methods. So which one to use depends on how much money you have. Look at that graph. You can see that the vertical axis is actually the performance. The horizontal axis is the cost. You can see that if you do a few things, then the cost will be increased by, say, 20%, but the performance go up by about 5 times. Whereas if you spend 200% more, then the performance go up a little bit more, but then you spend lots of money. So unless you have a lot of money, then you have to decide where to stop your design technique. So we find that actually somewhere here would be the best. So this is how we look at the performance and also cost effectiveness when we come to designing real buildings. Natural material, as I told you, is very cheap because they just gather it from the field and then you just model it a little bit. But sometimes you have to use modern material to help you, like a bit of polystyrene and things like that. Then it will be, you have to combine some of the modern material with the traditional material. But the traditional material is about 90% of all the materials. So the embodied energy is very, very low. This is the kind of design that we make. Very simple, modular, so that we can replicate it. But then on the other hand, we have to arrange the modules so that they form different kind of outdoor spaces for the winter and also for the summer, for the children. The level changes according to the topography. So it's a very simple kind of building that we have designed for them. And then we asked the villagers to build it themselves. Their workmanship level is very low, so your design has to be very rough, very tolerant to kind of low workmanship kind of way of doing things. But as you can see, mostly built with natural materials, low embodied energy, but very effective. So this is the final product after a few months of the villagers building it. And you can see the 2 courtyards. The smaller courtyard has trees planted in it, but they need time to grow. So this is how it looks like eventually. And we did the calculations and we did the measurements to compare with the calculation. We found that actually in the summer, the indoor air temperature is about 23 degrees constant. So it's very comfortable. And then in the winter, when the outside is minus 15, the inside is still about 5 degrees. So you just need another jacket or something. And the volume is calculated in such a way that every lesson is about 40 minutes. And after every lesson, they all go out. So they open the door, the fresh air come in, they fill the room. And then they come back in, they warm the children will warm the school for you. Each student is half a kilowatt, you know that, yeah? Okay, so you see, your students are good. Yeah, half a kilowatt. Yeah, yes. If you don't have a student, you need 2 cats. Okay, that's the same. Or 1 cow is 5 people. Okay, so if some of the student doesn't come to school, you just bring a few cows into your classroom, you'll be okay. So and the daylight is provided on top. You can see so the lighting and the air quality and everything else and thermal quality are all ensured. Now, the one thing that happened is that after our school was designed, a nearby school, 11 children died of carbon dioxide poisoning, burning coal in their classroom to keep warm, okay, and kid died. And then lots of people ask whether or not we can design a better school, and this is the better school, because you don't need to burn cow dung in your classroom and die. And then we gave Foster another hard time, and in 2009 we won another RIBA. In that year, he also ran another one, RIBA. The Beijing Airport Terminal 3 was by him, £2 billion. So he did not ask me to go back to his office to give a lecture, because our school is only £30,000. So we can build so many schools. Oh, by the way, the same year, the bird nest by what? Who is it by? One of these funny architects. That one. Yeah. Huh? No, that one. Who is it by? Who? Oh, one of those. Okay. No, he also got an award, so it's okay. Okay. Herzog, And then we decided to set up a charity to continue our work together with our students. This is what we call the Bridge to China charity, to make sure that we can do more. So the students' studio projects, or some of the things they are going to do in the summer is going to be by this charity. And then, sorry about the Chinese, but then we do a lot of good things, and then we involve about 20 universities around the world to build more bridges. I think until today we have built about just under 100. Not many, but then thousands of students have participated and experienced what we can do to help people. These are some of the examples. They're all designed by the students. The only criteria is that they have to be very cheap. So if the student designs something very expensive, they have to ask your mom, their mom, not my mom. And then we have one honorary patron, or Sir David, and he told me that actually it's not the bridge that matters, it's the people who build the bridge that will be forever. It's very true, because the bridge comes and goes, but the people's idea will stay if you train the people well. And then if you train enough people, I told a lot of people that I only need to train 2 students, and if they can train 2 more, then in no time at all, everything will be done. So this is how small efforts can sustain. And then we hit a problem about 10 years ago, the earthquake. And this is how they move in and out of the village. And this is their house when they go home after the earthquake. And this is the village surrounded by the river. So there is no way that they can cross except by this bamboo plank bridge. So that was the situation. Nobody went to help them, and we cannot ship anything into the site, and we cannot even bring anybody, like a contractor or workman, to the site. So what are you going to do? And there are about 35 houses all collapsed. So can you do something? So this is the old lady that we tried to initiate our help. And then we try to find a way to use natural material, because there's no way that we can bring in any new material like concrete and things like that into it. A small bed of cement is okay, but anything else is no go. So we test we try to utilize the destroyed house earth, and then we construct it in such a way that it can be load bearing, and then we know exactly how they fail. And then we also push it to see how they resist the next earthquake and things like that. So we did the test on site to make sure that we know roughly how to use those recycled material. And then we also designed the building in such a way that they interlock to each other. So all the elements are locking to each other. The timber, the rocks, and the mud are all kind of come together. And then we improve their tools and their work, the way that they work. And then we publish a booklet to teach them how to do it. And but that's not the end of it. Each house is not a kind of a standard house. Each family, the student went to a survey, and if they have more people and they want their toilet to be on one side and things like that, each house is different. So it's their house, it's not the house that we designed for them. So they recognize their house. Some of them want their cows to be underneath, some of them want their pigs to be on the one side. So when you design for people, we understand that to be sustainable, you have to design for that. For them, that they want the space they want, not the space you want, or not the space that's the easiest. But then, on the other hand, we had to find a way to modularize it. So you can see that actually they're actually very modular. They just shift around a little bit, get bigger, get smaller, and then do a few things. But they're all one kind of structural system, but many different kind of spatial interpretation. And then we gathered all the villagers and teach them how to do it properly. So this is the first house for the lady. And we teach them how to prepare the material, how to lay down the bamboo reinforcement, how to put the walls up and things like that. We teach them how to do it. Because after you're gone, then they need to know how to do their building next time. And then 3 months later, the old lady has her new home. And then the villagers went back to their own home to build their own houses. The three red circles are the buildings that we built. The rest are by the villagers themselves. So we send our students to supervise them a little bit, and they just build their own home. And self-help and no help from outside. And in about 6 months' time, the village was rebuilt. And we also built them a bridge, you can see. And then our students built them a community center. And then this is the piazza or whatever. That they like dancing, so we designed something so that they can dance. This is how this is all by students. So after they work, they do this. Okay, not to show what's happening, but anyway, or they do that. Okay. So we try to kind of melt into the community in a way by designing and building a little structure for them. And we also went into the village to do a few things, the water supply and eco toilet and things like that. And this became the World Health Organization's first, what we call the health village in China. Because the World Health Organization have a certain things that you must do to qualify that. So this was applied to become the health village. So become an example. So surrounding people can then learn how to do it properly. We also, of course, do performance evaluation. The outdoor-indoor temperature goes without saying. But the cost is much lower than if you were to employ somebody to build the concrete framed house for you. It's only about 200 instead of 1,000, so 1/5 of the price. And now, of course, the satisfaction is high because it's their house, not our house. And I like this particular photo very much because after the reconstruction, they restart their life, and this is how they plan their next year's crop. in front of their new village, so-called. Okay, but then lots of people ask, once they have money, will they therefore forget about earth houses and go for this kind of Spanish villa and things like that? They may, but then can we do something? So we start our investigation in one of the village where the arrows is, and you can see that this is the seismic hazard map of the world. The red areas are seismic zones, and many millions of people live in those areas. But we work in that spot there. This was another earthquake that we was called to respond to. And this is a situation after the earthquake. And this is the old lady again. I like helping old lady and old people. So if you get old, don't worry, I will come to help you. But then I will be up there somewhere. I'll help you spiritually, okay? Thank you. So they after the earthquake, what do they want? They don't just want a house. They want a new life. They need a life that is better than what it used to be. They have to stand up again and live life. And that is the more important thing than to build them a house. A lot of the time we go in, NGO, we build them a house that they don't want. They look horrible. And then they say, you are one of those people, okay, so I give you a small house, No, you don't do that. You have to give them what we call the dignity. They must be very proud of their new life. So that was the motivation behind our architectural intervention. So we set up a few principles. Okay, we must reuse the material, it must be safe, and we must teach them how to do it properly. And more importantly, we must add to their life somehow. So we team up with a few people, one professor in Cambridge, she's a seismic resistant kind of expert, and then other people to design something that will stand up in the next earthquake. And then we have already learned how to use local material, local worker and techniques. This is the lady. I've talked to them. And first thing you have to do is to see where the problem lies of their earth houses. So we dissect the problem. And then we come back to the laboratory to see how we can improve the material by mixing different kind of material, different kind of soil together to perform in such a way that it becomes almost like concrete. So you have to find a way to make sure that that yellow line is within that the gray bar. Then you should be okay. So otherwise you have to remix the soil, you have to add something to it, you have to take away something to make sure that it behaves. So this can be done scientifically using the material science understanding. That's easy, but you have to do it. And then the design, as I told you, has to be modular, but also has to be spatially useful. So as you can see, this house has 2 modules. But then the space in between is the most important space. The module approach allows the building to be very, very rigid. But then the spatial organization has to conform to, or has to satisfy what the occupant wants. So in this case, the old lady. So this is how we design this very, very simple building, extremely simple. If you do this in your studio, you probably get a C- or D+. You know, students, when they do design, first thing you do is, oh, nice, look nice. You get a B+. This is C-. Never mind about the C-, okay? Let's start with C- and see how it goes. And then we test it so that what we are trying to do is safe. So the 2 diagrams are different kind of seismic resistant, seismic waves pattern. So we have to test different pattern of earthquake to make sure that when earthquake come in different ways, they will survive. And we test a number of them, and then it survives. And it also satisfies the China 8th degree or whatever requirement. So this is satisfied the national standard. First time that earth building can satisfy national standard. Before that, it cannot happen. And then, of course, we also do the cost performance analysis that you have seen by using our understanding of the psychometric chart. You all know psychometric chart, yeah? Good, thank you. Yeah. This is again the cold weather, yeah, you can see, and dry. Okay, we have to teach the workers how to mix the material, how to pound the wall, because how you pound the wall matters a lot. You have to compress it to a certain extent that it becomes almost like concrete. And everybody has to know how to do it. We add some straws. And we improve their formwork, because if you have to pound it very hard, then the traditional timber formwork doesn't work anymore. So we have to use aluminium formwork. So we introduce a modular formwork for them to work on it. So it's the quality is much higher, therefore. And we taught them how to do it, and this is the owner of that particular house. It's the son of that lady. And now he's our contractor, so he's now making a living by building these kind of houses for others. So we're introducing skills to them. And as you can see, we introduce also new tools, now electric pounder. So therefore the soil can be pounded very, very compactly. And this is how it works. And this is the end product, or the square house, as you can see. Very simple. This is the old man. And this is the in-between space that the old lady now enjoys. Because we talked to the old lady, she do needlework. And she has been doing needlework for her whole life. So okay, if you want old lady to do needlework, so what kind of environment you need? You need somewhere that is cold enough or warm enough, and also bright enough. Okay, so this is how the space works. And this space the temperature is so constant that she has air conditioning whole year round. In the winter it's warm, in the summer it's cool. And because the two sides are perforated, so the wind can blow through a little bit of air movement, very bright. And some of the leaves falling onto the roof, the skylight kind of. When the sun shines onto it, it kind of dances a little bit. Nowadays, you not only use this space for needlework, because so many villagers like this space when the outside temperature is so high. So she charged people to come to her home to drink tea now, which is very good. Okay, so she's very proud. And then to be okay, and then she now has a house that can earn money. And we did the measurement. I mean, you all do measurement after your design, I hope, and it works very well. The cost is only half of the normal cost using concrete and brick and other things. So it's very cheap. The performance is good. It's very strong, and everything. And also it was featured in AR, and we got the World Building of the Year Award 2017. So it's not a C- project, I can tell you. One of the judges was Ian Ritchie. That's why. And then we also nowadays drawing up the new code of practice for the local government, so that they can regulate some of this work and make sure that things are more properly done in the future. As I told you, we don't build them just a house. We give the old lady her life back, and with dignity. She's now the proudest person in the whole village, because so many people go and see her house, and she charges people. And from then on, we also start to do many things for the locals. Based on our one university, one village, i.e. using the university know-how and combined with the village people's wisdom, we try to find a way to do village better. And there are a number of principles, so I don't want to bother you unless you want to do a PhD with me. And so these are all my PhD students' kind of structure of whatever. Basically, it's just to fill up the pages so that the PhD become bigger. At the moment, we are doing about 150 on site. We have 4 construction team, all formerly only villagers. So they now help to design building, construct buildings, and also make a living. And this is our latest research center in Kunming, built entirely of, the main structure of ram earth. One thing I want to show you is in this building we conduct further research on materials and construction. We train people and we also host events. So when you have nothing to do, you can come to China and we can teach you how to build this kind of wall and get your hands dirty and have fun and go to the old lady's house and have tea or whatever. This group of the red helmet viewer is very fun. You know, in China there's a problem that villagers, a lot of the men goes out to work, yeah? The villagers left behind the old people, the women, the children. We call it village that is almost empty in terms of life. The red helmet group is China's first all-woman construction team. Okay, so we organize them so that they work to build their neighbor's home. And we taught them how to do it, and we had to resize the formwork and the tools so that they can handle everything. And after a few projects, we find out that they are more reliable, work harder, don't drink, don't sleep.
And very healthy.
They're very healthy and very good and understand what you want them to do exactly. The men always say, oh yeah. So nowadays we have 2 of those teams. Sooner or later, they will replace the entire men's construction team of our project. They are very reliable, and they're also very good. Okay, they take the money home. The men take the money to casino. So, okay, that's another way to revitalize the village economic, social kind of structure and things like that. So the women are now very proud of themselves. So when the man comes home, the woman will say, sit, okay, that's it, okay? This is how it should work. Actually, I learned it from the Bank for the Poor, the initiative in India. Is that right? Something, Poor People Bank. So they lend money to the woman. They don't lend money.
Credits always go to the women.
Yeah, always, yeah. Women are more reliable. You lend it to the man, he's finished. Sorry, man. This was the first house that the women teams finished. The quality was much higher than what the men could do, and we now use it as an example. We show the men team how it should be done, but they never want to know. Okay, we come back to the 8 words that I start my lecture. Actually, this 8 words was by somebody who is has a lot of wisdom, not me, okay, not me, okay. So they say, okay, you must do 8 things when you start your architecture or whatever career. You must do 8 things. And I showed these 8 words to my vice chancellor, and he's a very good calligrapher. So he wrote the words for me, but then it was from somebody else. Okay, how many of you learn how to read Chinese? Okay, all of you, thank you. Okay, right, so you know exactly where it goes, so I don't need to explain anymore. Right, Chinese actually, you know, it reads that way, yeah? Yeah. From the bottom to the top, yeah? No, from the top to the bottom, okay. So, can I have the it's almost done. Now I need this because my finger is not allowing. So it starts there, and it goes there, and it goes there, and there, and then it comes down there. So there are 8 words, meaning 8 things that you must do. Okay, I'll show you how. And in architecture, in any project, you also need to do things in your life to make sure that it becomes meaningful. Okay, the first is, of course, we start with earth. Something that is worthless, something that is so simple, something that nobody take any notice of. So sometimes you have to start with something extremely simple, and don't start with something complicated. Something that is beautiful in its own right. And then you can see that these are the areas that they still build this kind of earth houses. And I can tell you that half of the world population live in those areas. So if you can solve that problem, you solve the problem for half of the earth population, i.e. 4 billion people. Okay? So it's not a small thing that you are doing, if you can solve the problem. Okay? So don't underestimate the potential, the significance of something very simple. And of course, you have to apply your knowledge. You learn enough to know exactly what to do, how to mix different kind of things to achieve a certain kind of performance. And you have to feel the material, you squeeze it, you taste it. Oh yeah.
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 May I add something?
Yeah.
I'm from Wageningen University, which is an agricultural university, and we have a professor doing soil science with the students, and when they go out in the field, he has the students taste all the soils.
Yeah.
So Edward is really not kidding.
No, I'm not kidding. No. You taste it, you say, calcium, yeah, potassium, okay, whatever. You really have to taste it, otherwise you don't know what you're doing. You squeeze it, you taste it, you massage with it, you play with it, and then you have to know how to work with it. Okay, what other things you must add to complement it. All these other things are very simple things, but most of these things I can tell you the villagers know how to do it. So you have to be humble and learn from them. I think to be an architect working in the field, first thing you must do is to be very, very humble. Okay, I'm quite sure next time you go to site, you will know that. They can lay bricks faster than you. Yeah, things like that. Okay, never mind. Oops. Okay, and then you have to, of course, apply your scientific understanding to test it, and then try to build something that is, I would say, simple but poetic. Okay, when I designed this building, I told my students that the only thing I want to express is earth. So if they see this building, they see earth, and that's all they see. They see nothing else. They don't see geometry. They don't see gymnastics. They don't see nothing. They see earth. That's okay. So this is another building, and this, you can see that all my buildings are fundamentally what the material wants to say. Then we try to find a way to design our building to achieve kind of a poetic feel. My teachers always told me, my teacher was Dean Hawkes from Cambridge. He always told me, he said, Edward, since you are with me, I may as well teach you something more useful than you normally are taught elsewhere. When he say elsewhere, it means elsewhere. He said to do something environmentally friendly and achieve a certain performance is easy. But at the same time, if you can make sure that it becomes poetic, it's far more difficult. I could not understand what he was talking about for many, many years until I start to build something. The poets of the earth has its own language. You should not just compose sentences. You have to compose poems with your architectural skill, and this becomes something that I think is most important to do. And I can tell you that our engineers very often cannot do that, because they don't know that this is important. But as architect, I strongly advise you that don't build buildings, just compose poem. Forget it. Okay. Never mind. Okay, and that doesn't mean that it's only poetic. It means it has a substance. It has a theory. It has a reason. It has a vision. It has something behind that is far richer than the material itself. Okay, so we incorporate into it life cycle understanding, sustainability understanding, human understanding, and then the kind of habitat, kind of people's use kind of understanding. at the end of the day, if she is happy, then your architecture has a lot of meaning. Otherwise, it has very little meaning, even though it is very strong. So actually, when I was designing this house, the space was the one that I spent a lot of time. The amount of light, how the surrounding come together, how the toilet face into this. The toilet is on one side, but if you open a door directly to the toilet, you know what happened. So actually, within that door are two doors. So the toilet doesn't come to the space. So you have to do some small things to make sure that this is a space. This is not a corridor. Okay. This is next time you come to Kunming to see our research center. This is how one part of the research center looks like inside. As I told you, my building is I use earth. So the building is earth. Okay, so you see earth. You only see earth. And this is the highest quality earth work that we can now do in the world. A lot of people come and see what kind of quality that earth can get. And we use this to teach the villagers that actually earth building can be extremely beautiful. So when they come to this building, they see this and they see some other things that we did, they go back and say, yeah, this is something I want. This is not poor. This doesn't mean that I cannot afford it. This means that I'm more than able to afford it. Therefore, I want to do something better. Oops. Forget about that one. Okay, now with the very beautiful things, we start to teach people how to make walls, how to make buildings. This is not by us. I think this is also by Herzog. Yeah. Yeah, after he sees us doing some earth building, he's trying to do earth building. But his earth building is very expensive. This is us. This is ours. Now then, after we start to improve people's life by making walls and homes, and we have to write codes, we have to standardize it, we have to make sure that everybody know how to do it properly. So we're now teaming up with some engineers to write a national standard on earth building in China. It takes a long time, but you have to do that. Otherwise, nobody will copy you. You have to standardize it. And you have to this is one of our earlier cultural practice, how to do it, but this is not official. So we have to officialize it, so become a national standard. And we have to publish something to make sure that we spread our knowledge. This is AR, as you can see. And then we have to teach the villagers how to do it. Teach others, teach students how to do it. The next generation has to know how to do whatever you have discovered, including women, of course, and the man and the woman. Okay. The good thing about it is you can see that all the women are working, all the men are looking. So this is how different they behave when they come to the training session. And these are the better one. The worst one at the back smoking. And we team up with a lot of universities to do a few things. At the moment, we are working with Habitat for Humanity. They have a number of sites in China that utilize our methodology and workmanship to build houses. They are much bigger than us, so they can build more. They build 100 at a time. But we have to teach them how to do it. As I told you, this is our research center. And then we have to find a way that our architecture and life is in harmony. Your architecture has no meaning until people use it. I cannot say that any more than I need to emphasize. Your architecture has no meaning whatsoever until people use it. So a lot of time when you see a photograph of architecture without people, you know what meaning it tried to give you. Our photograph always have people, otherwise it's so empty. Doesn't look good. And then we are now doing the entire village, not only just the house itself, but also the space around the house, how the whole thing organized. So this is one of the few villages now that we are doing en bloc. So this is the design. It's a more kind of organic layout, and outdoor spaces are now important for us. And we also try to incorporate the United Nations sustainability design goal, so 13 of them. And under each one of them, we have to tell the United Nations what is our way of doing it, achieving it. So this village that we're going to design will be the first UN fully subscribing to the UN 13 SDG goal village. And then maybe next year we'll present it in the UN Habitat or whatever they call it. Oops. Okay, and then the next word is that you have to not only work in China, but work everywhere else on Earth. So we are trying now to do a few things in Nepal, in Cambodia, and surrounding areas. So we are now spreading out to the other side of the boundary. So you have to find a way to make sure that this becomes international. Okay, so you talk to people. So we are now working there. One day we need to work everywhere. But you, of course, cannot do it yourself. So you have to find a way to combine it with your academic pursuit and your team and things like that. So these are the few people that work on Earth buildings around the world. As you can see, Anna is this guy. She's a lady from Switzerland. She built this guy. Yeah, you probably know this one already. Yeah, and then there are others by other people. This guy is from Cambridge. This from MIT. And there are many in Japan. This one won the whatever picture award in 2012. Yeah. Sugar bar. Yeah. He also worked on this kind of natural material. But I always find his building a little bit too articulated. But anyway, that's his way of doing things. So you have to combine different people's expertise and form a group. So every 2 to 3 years, we kind of meet up and share with each other what we have achieved. And so the whole message kind of is more kind of widespread. Now, the last but not least, the most important thing that someone taught me is that you will die soon. If someone, you will die soon. What would you do? Give a room. My son sometimes once asked me, Dad, when are you going to die? and then he keep on saying, no. He said, what are you going to leave me? That's the son that I'm going to have dinner tonight. Anyway, are you sure? Then I say, son, I'm going to leave you a better world to live. Is that all? Okay, fine. But on the other hand, the most important thing is that you have to find a way to sustain your effort, that your next generation knows how to continue, because you cannot finish it. And this is the reason why we work with young people a lot. And this is the man who taught me that this is the most important thing you should do. I.e., you should not do it yourself. You should teach people how to do it. Yeah. And then they can then be inspired to teach more people how to do it. And they will do it better than you. That's what he said. I say, is that all? That's all? Yeah, Alice? Yeah, okay. So I have one student here who has been inspired. But these are the people that, not this one. This is my vice chancellor. He come to the site and say, where's the toilet? I say, there's no toilet for 2,000 years. You just do it that way. Anyway. But these are the people whom I think we should inspire. So, i.e., you are the kind of people that I wish to inspire. One day you need to find a way to help people, and then there is a structure to it. Okay, from very simple things to very beautiful things, from teaching, from material, from everything. Poetry, okay, something beautiful, give people back life and dignity. That's the kind of thing that I want to inspire you. So environmental sustainable design is not technical at all. It's about human. That's something that I think you should learn about this subject matter. Okay, it's never about environment, never about temperature, never about sunlight. It's about human and their life. And if you can do that, then I'm quite sure you know what these 8 words is about. Now, this calligraphy, the Vice Chancellor wrote it for me, and then I show it to somebody. And he likes it so much that he wanted me to give it to him. So I gave it to him. And immediately he gave me a check, £2 million equivalent. Next week, after I come back from Brazil, I'm going to ask him to write another one and give it to him again. Thank you.
We'll take some questions.
If they have questions, yeah, not technical one. Yes, sir. Maybe you, yeah.
Yeah, bit technical though.
Technical.
Not so. I see that you considering running. So how do you stabilize it? Do you stabilize along with the clay, or do you also use a bit of?
Good question. Very good question. Every time we come to the site, the first thing we do is to dig a little bit of soil back to the lab to analyze. Okay, if the soil itself is good enough, that follows the kind of the gray line, then you don't need actually add anything. But most of the time, I would say 90% of the time it doesn't. So you have to find a way to mix things like cooking. So sometimes we have to add lime, sometimes we only need to add some fiber, but sometimes we even need to add cement. So it all depends. So yeah.
So then I saw that most of the failures in the earth wall was a shear stress curve. So and I'm guessing to counter that you added fibers. So how does it affect the compressive strength? Because I mean, as I know that brick has a higher compressive strength than rammed, but since it's a rural area, you have thicker walls. So compressive strength will be naturally, lower.
Yeah.
And the next part of the question is, now these were rural contexts, like the higher impact would be in the urban context. So how would it translate to, because we can't have 400 centimeter sort of walls there, so.
You mean urban context?
Yeah, urban context. Right?
Okay, 2 questions. So first question is how we make sure that our earth is good enough. The test is very simple. The test is basically compressive test and shear test, 2 Pascal, 2 PA. Okay, if we can achieve 2 PA, it can resist the kind of shear that you need to resist in that kind of seismic resistant kind of situation. Okay, but if say you have a higher standard, then you need 2.5 PA. So basically, you mix the soil and then you test it. So if you achieve 2 PA, most of the time it's okay. So that is the basic test that you must do. Okay, that is. How about in urban area? Now, this kind of building is best to be constructed in areas that you have a lot of labor force, i.e. people have nothing to do. Now, because the material itself is free, but the amount of labor you need to construct it is higher than normal building because the wall is thick, so you have to pump it that. And therefore the labor cost is high. So if you need to pay for the labor cost, then the cost will be high. The reason why our building is so cheap is because uncles and aunties do it, the women do it. So if they can do it themselves, then it's very cheap. So in urban area environment, the economics, the cost performance economics is completely different. So at the moment, we try to save the other half of the world population first, and let the city population suffer a little bit more.
So could it be then reduced by prefabs?
Huh?
Could this be?
Yes, I think the team in Austria is trying to do that. But then on the other hand, as I say, if you do that, the cost is high. So the advantage of using the natural material is not as great as it were to be done in rural area. Because in rural area, there's no other choice. The cost is like this already. So if you do prefab and other things, you can experiment. But at the moment, we have not found a way to do it, to justify using it in city situation. Yeah, we have not done that yet. Maybe some others can do it.
No other.
Yeah, okay.
You can
I just want to say thank you for the presentation.
You have some money to donate?
Yeah, but because I think it's quite inspiring to see how the environmental science gets translated into architecture. That's very intimate and also very meaningful. And I'm just curious to see your thoughts on how some of the bigger firms are tackling sustainability. A lot of them are putting more and more focus into that. And I was just wondering if that there's a huge problem with performance gap with some of the newer buildings, and I was hoping maybe you can shed some light on.
Apart from doing this kind of thing, I also do a lot of work for cities. And actually, my next lecture in Brazil was about city environment and how cities should cope with this kind of thing. I think a lot of the time, my feeling is that architects are trying too hard. I.e., they try to solve a very simple problem in a very complicated way. I think that is the most of the time that it has been a problem. Ignoring that, once it becomes complicated, things can happen. I.e., people don't like it or something can happen.
And do you think that's because, in an urban setting, usually a lot of the projects are they scale very fast and very big, and that sort of loses some of the human touch and the human understanding of the building?
No, for example, I can tell you that if you want to make, in some part of the world, if you want to make a building very sustainable, you solve 80% of the problem by only one design element, called sun shading.
Sorry?
Sun shading. And lots of people, instead of doing that, go for very complicated coated glass, something funny, and then something stick around and move around and curve around a little bit. So we try to solve a very simple problem. And once you solve that problem, you solve 80% of the. So you then go back to that what we call the cost performance analysis. Okay, how many more things you should do? And then a lot of people say it's really boring. But no, if you can make sun shading, Graham Merkett, is that right? Graham Merkett, the Australian architect. Yes. I asked him, say, how your sun shading work? He said, I have no sun shading on my building. Hey, come on. He said, I have sculpture outside my building. Okay, fine. And he solved 80% of the problem already. So 20% of the time, 20% of the problem, if you have lots of money, you can solve it again. So I think most of the time, if you design building in any context, try something very effective and simple, and use that simple thing to express your building. Then that simple thing is very meaningful, very sculptural, very nice. I use earth to express the language of my building, and earth solved 80% of my problem already. So use that to be the language of your building, not try to do something funny. I know, of course, something funny is funny.
Don't say that in the AA.
Huh?
Don't say that in the AA to know.
No, AA do something very nice. And funny. No. It's one way to see how we can make architecture meaningful. That's all.
I have another slightly technical question.
Oh, technical.
So,
you asked me to value it.
no. I'm just curious of how do you assess different adaptive comfort bands for different places? Because I'm curious to see if you believe in all these standardized comfort bands that can be applied to,
No, I don't believe that.
Because the Assure 55 is sort of worldwide, and for example, like Hong Kong as a context is very hot and humid, and I was just wondering if you do some preliminary studies or analysis when you go into a new project and sort of identify what are the adaptive opportunities for that particular.
We never use the world standard as the basis of our design. We never do that. But we refer to them and say, okay, this is actually standard, roughly how they do it. But the most important thing is that you go to the village, you look at how people behave, how they dress, how they stay. You roughly can guess what kind of environment they want. how they, especially how they dress, how they rest, how they position themselves during a hot day or a cold day. You roughly know, and you know that they can not tolerate, they are accustomed to a certain way of living. So once that you sketch, you say, okay, this is the way that they sit under the tree in that kind of environment. Then you know how to design the kind of environment they want. So my suggestion is that those things that you learn from books are for fundamental understanding, but you really have to know and look at people how they use space, especially in area or in cultures that you are not very familiar with. Okay. I mean, in Germany, the comfort band is 24 degrees, I've been told. But in Hong Kong, about 29.
26.
Yeah.
But also adaptive.
Yeah, adaptive or whatever. And at 29, people will find a way to be comfortable. And you have to see how they do it. Oh yeah.
May I add something? Because all the rules and norms and calculation procedures and so on, they usually define the minimum, not the optimum comfort, but more, minimum standards and so on. And you should keep to that so that you're on the safe side. But it does not necessarily have to do with a very good quality. The lighting is the best example. And you have minimum values given, but it's not the case that this is good lighting quality. It has nothing to do with each other.
I did not show you some of the slides. In the school that we are building, we have built, the way that we tackle that problem is that we know different people have different way to comfort. So we actually design different spots in the school that children can find, that they have different comfort experience. Some of them are a little bit hotter, some of them are cooler, some of them are a little bit more, have more shade, and some of them close to the wall so they get a cool radiation. So what I want people to do is, if your building has a diverse kind of environmental spaces, i.e. spaces with different kind of environmental conditions, then those are the spaces, those are the buildings that will likely to be more satisfied, because people find those spaces. So one of the things is that if you can design a building that people can see, find, and reach the spaces they want, and they know that in that area it will be cooler, then people are more satisfied. That's actually Luke's customer told me. He said if you design an outdoor space, make sure that the outdoor space has 10 different kind of environmental conditions. So you put fountains somewhere, you put trees somewhere.
There's also a nice book about it, Architectural Diversity, by
environmental diversity. I never quote him, so Kun, you mean Kun? Yeah. Who's that? Yeah. Kun was my classmate.
Really?
I never quote you. Yes, madam.
Your lecture was called Mud and Bamboo.
Yes.
You talked a lot about mud.
Yes, I have bamboo. You want more?
Okay. Part of the reason,
I've run out of time.
No, all right, I understand. But part of the reason that I asked is I lived in Papua New Guinea for a year, and there was a 7.5 earthquake, and hardly anybody was killed because bamboo house, etc. I lived in West Berlin in the 80s, and they used they trained the squatters to renovate the buildings they lived in. I mean, these are different versions of what you're saying. Because it was only mud, it got very concentrated onto earth. But I feel one mustn't forget that in different local situations, different materials may apply. That's all. I'm just being naughty.
You're not naughty. You're. Okay, I just finished part 1 of my lecture. Now I start with part 2 now. You'll be here forever. No, I won't give you a lecture, but I will just flick through the slides on bamboo that may be of interest.
Has its own issues and climate and all that stuff.
This is actually not exactly. These are my students who gave a lecture, and I use his. So we use bamboo to build bridges in that area. We learned from that.
Of course, yeah. You did mention that.
Yeah, I'm not going to talk, so you just see how the process looks like.
Yeah.
You cannot talk about bamboo without talking about panther, you know.
Of course.
Yeah.
Now they're using bamboo to do this, you know.
No, that would be helpful.
And we have been using bamboo for thousands of years. And in China, this is the first group of people who investigate bamboo about 60, 70 years ago, because at that time there's no material, only bamboo. So this was, and then the best bamboo craftsman is this man here. He built this bridge using these tools. How about that? So these are more modern interpretation, okay? So we did something here. This is the situation. Then what type of bamboo? How to test it? Again, you have to apply your scientific understanding. This is the design. This is construction. The first bridge. This is the full bamboo bridge. This is how we celebrate. This is the first 17-meter bamboo bridge, fully bamboo. It's I think the first in China, the longest. This is how we celebrate. This is a very good story, I can tell you. After we built the bamboo bridge, we wonder how the maintenance cost should come from. And they invented this. They put it there. Now it's a bamboo temple. And they donate money. We have maintenance, we have now money for maintenance for the next 200 years. And they make it into a community center. Funny how people look at some simple architecture.
So it's not a bridge, it's an open building now.
Yeah. It's a bamboo temple now. This is another bridge, and then we did more tests on durability. We now can find a way to build bridges that is 30 years, that lasts 30 years. And jointing is the most difficult thing to get right. A lot of people told me that bamboo is very strong in tension, yeah? Very weak in compression, yeah? Wrong. Bamboo, when you try to join them together, is very strong in compression, extremely weak in tension. So every joint that we make is compression, because jointing is the most difficult part of bamboo structure. So this is, and then we investigate about 20 ways to join things by compression. So you can see, so you see, this is all by compression, not by tension. Because if you tear the bamboo, it's very weak, extremely weak. One piece of bamboo is okay, but if you try to join two together, it's always compression. Okay, this I have to teach you this because it took us 5 years to find out. And different way to join them, and we have to use the different a lot more tools than the old man. This is our second. This is 22-meter span bamboo bridge, fully bamboo. Now it become the cinema. And at night, you know what happened? Because the floor is bamboo, yeah? So it's perforated, it's very cool, so they sleep. So they always try to make sure that the width is more than 2 meters, so that they can sleep like this. So about 20 people sleeping there in the evening, and this is. We're now building a much bigger span. This is the second bamboo bridge. Have you seen this one? This is the largest bamboo span in the world, 35 meters. That's also by us in Beijing. So this is one span. So if you can do a span like this with bamboo, totally using bamboo, then we can do a lot of things. Inside is like that. Forget about the decoration. We just look at the how it come to. It's all compression joint. So this is the longest spanned bamboo roof in the world now. And we're now writing the China's national standard on bamboo structure at the moment. As I say, once you find out new things, you have to codify it. Otherwise, nobody will copy you. The more important thing is, difficult thing is how it come to the end. Because bamboo doesn't like a few things. One of them is water. If moisture comes to the bamboo, it will rot away in 3 months. We're now building anti-seismic school buildings using bamboo. Okay, never mind about this man. So this something. We are also now experimenting with using bamboo for houses. But we are still experimenting. Some parts of the world, their earth houses is no good because you don't need the earth performance kind of thing, especially in hot area. Earth is useless. So if you work in Philippines, for example, then bamboo or something light. Okay. No more question.
Okay.
I also have some stone, no?
The lecture is called Modern Bamboo.